win and you win. So there is no loss. Similarly, way if you lost, then the lost the game, then there will be loss. Similarly, way, right? So let's assume you are preparing some pancakes, and you have some kind of taste for the pancake, and it should be perfect pancake, and it should be brown pancake. You are assuming it should be round, brown or something, but end of the day, it is not brown at browns or something like that you see. So there may be some loss, which we consider a loss. So this is similarly, we are going to calculate in neural network, right? So there are various different kind of the loss function is available. So first we talk about this is loss function, right? And they are divided into two parts. And I can say they are classification. It's kind of classification, and the similarly other way we can say is the regression problem, like linear regression or something. So there is also loss for that one. Regression, I am not checking about the spelling. So these are two kind of things, right? So now let's assume the classification also have some different kind of loss function. I can say they have like binary cross entropy and category. Binary means 0 and 1. Binary cross entropy. So this kind of loss function we have, and then we have one more loss function in the classification, which we call is a categorical cross. One is binary, other is categorical. So cross entropy is the name. Category cross entropy, something like that. So spelling, don't take about spelling. Then in regression also there is various kind of things. First one is mean. Here we have most of time mean square error, MSE. So this is very important. If you know the machine learning, it's very important. And most of mean absolute error. So we can say mean absolute error, right? Mean absolute error, MSE. So similarly we, and then this one, for example, where we use this one. Okay, 0 and 1 where you use in daily life, you have email, right? And email can be spam or it's not spam. So this is 0 and 1, right? And fraud detection, also one of the example, fraud detection. So these are the example. I'm not writing. So, and the categorical example you guys can give me. So some image classification. So let's say you have image mango and orange. You want to find whether it's belong to mango or orange, or there may be some language detection. So these are the classification of the binary entropies, right? And we can put like this, and this is under this. You guys can learn this one. So basically, we divided into two parts. And the regression is the house regression. If you can give example me, the house price is a classical example, right? And the similarly way stock prediction and something like that. But for mean average, the absolute we can say is very accurate. We need or no, not accurate, like something like age estimation or delivery time or something. So these are the broad levels and which we are going to talk about high level. So loss function, what is the loss function? Think about loss function, a mistake counter. Perfect sort is 0, but near miss very small loss. Complete miss large loss. These are the loss, right? And so if you see here, so real life example, you are learning the pancake. Target is perfect golden brown pancake, but how far your pancake is perfect? This is more on your practice. And lower your errors, it's become more. So this is like loss function classification regression, which I already talked, right? And classification will be, is it A or B? Okay. Okay. The similarly loss function, is the email spam or no? Is the image is cat or not? Okay. And this is a simple example for classification or binary. Binary means 0 and 1, spam and not spam. So this is how this is used. They use log function. Log function basically give you 0 and 1. And this is how we do, right? And now binary cross entropy log function. This is what log function I gave. Binary cross entropy log function, lower log loss, better performance, higher log loss, poor performance, right? This is a very classic one. So see, categorical cross entropy classes CE equal to minus yi log P. P for probability. So consider the model, guess the type of vehicle and image in 5 options, right? So which one we are looking, so we can check. These are classification, whether it's car, vehicle, or something like that. And I'm going to here the regression problem, which I talked earlier. So loss function in regression is mean square, the house prices, temperature forecast, student grades, and so on, right? And this is the formula 1 divided by n into sum of y minus y and square, predicted value for ith sample. This is predicted value for ith sample. Mean absolute value is the similar 1 by n, 1 by n. This is absolute, this is square. This is the only difference, you guys know, right? And you can see here average. I calculate mean absolute preferred scenario is delivery estimated time age prediction. These are very important. Similarly, this is what. So actual time 30 minutes, predicted time 35, and linear the error is makes the pipe is difference. So this is the error. Lower value. When to use the loss function? Use binary and cross entropy when? Yes and no. Working with the probability example fraud detection or something like that. It's very, very important. And then use mean square, predict exact numbers, large errors. A really bad example, stock price is very, very important. So that when we need mean square. Mean absolute, predicting range value, right? For example, movie rating prediction or something like that. Remember, how do you remember? Classification is cross entropy. C and C, you can remember like that, like true and false. Exact number, MSE. Approximate angle, MAE. Likelihood house price, motivation, I mean, every great AI application, Tesla self, I mean, this is very important. So what I'm trying to explain you guys, practice, practice, practice. So every expert start with beginner, keep learning, and my code is here, guys. You can go through GitHubs and everything is here. I put a code. So now very small example which I have given here, and you guys can go here. So let me run. This is the program which I have written. So basically this is main program, and then loss function, we have various loss function, print. So it is running, and this is what output I got. I can put here for you guys and can walk through it once again. What I'm trying to do is here, let me put here for you guys the output, and let me walk through this program, what it will do. Okay, so basically spam detection BSC loss is this one. Okay, and now the run all the code. Loss function action. Loss function action should be somewhere here. Loss function action. Loss function action, it should be here somewhere here. I missed here. Loss function action. Yeah, this is first part, right? And then it will go to here, and then it will go to spam detection. Spam detection will come the y true and y prediction. So this is true value. It should ideally get, but we got this one. So loss function for binary entropy y, and this is y. So now we created one more function, loss function dot binary cross, loss function dot binary cross. Okay, it may be here somewhere. Loss function dot binary cross, so it will give the difference. So this is basically, this is class, so we need to call like that. And y true, y predict, and ellipsion is equal to this power, very small number. So they need ellipsion and clips y true and np log y prediction, right? Y minus y true np log y. 1 minus y true np log 1 minus prediction. So this is what the return is. And when we returns, and it will detect spam is very likely, right? There might be not spam. So spam true means 90. Spam 0 means somewhere it's 80. Spam, not spam 20. It's true 20. House price is 85, but mean square loss is 85. MAC loss is 9. Detailed prediction 200K, 190K, errors 10K, 10K. So this is the less error. So I think we can use this model. So please like, share, and subscribe my channel.